For a very long time, the Earth worked in an energy neutral way, wherein animals and plants coexist in a continuous cycle. But then came a time when man discovered fire, then followed by more discoveries, including the discovery of the steam engine that marked the Industrial Revolution. Humans have tried their best to provide a more comfortable lifestyle by inventing newer devices and technologies. And with these developments, it slowly transformed the environment. And now we are facing a number of serious issues and challenges in the world. Like, for example, the rapidly increasing population and urbanization. This has resulted to very big pollution problems, increased demand for our resources like water, food, and energy, and the changing climate is making matters worse. Hence, we need to act promptly to make sure that we can still live a quality life at the present, but without endangering the life of our future generations. So, this is basically the concept of sustainability. Or we can say that sustainability addresses the ongoing capacity of Earth to maintain life. So, tackling these world challenges has led to the adoption of the Sustainable Development Goals, or SDGs, in 2015. And this was done by the United Nations member states that serves as these SDGs serve as a blueprint towards a more sustainable future. There are 17 of these SDGs here that are interconnected with each other. We can see from here like no poverty, zero hunger, which is related to food. There's a gender equality here. There's also clean water and sanitation. But if you look at here, there's also what we call the provision of affordable and clean energy, which is the focus of our class. So basically, the goal of this SDG, it is hoped that all of this will be achieved in 2030. So energy is very central to everything that we do, from eating to going to work, using machines, like powering our mobile phones, for example, lighting and heating our homes, among others. It is a very critical ingredient in all economic endeavors, which is essential for human needs, the provision of or to meet the human needs. But really, the big question is more on if the energy produced is cheap, which is related to affordability, or is cheap enough for majority of the people to use and to produce as well, and how sustainable and clean the energy is without damaging the environment. So part of the strategy of this goal, the SDG number 7, is to increase the uptake of clean renewable energy in the overall energy matrix. And this is part of the discussions we will have in our class for sustainable energy resources. So what we see from this table, if we look at the history of our energy use, we see that our society has actually changed the way we use energy from, let's say, for hunter-gatherers here, we usually use our body's own energy. So we produce our own energy from our bodies, and normally we use this one to use for stone and iron tools in order to survive at that time. And then most of the cases when the early people have started to use fire, they use a biomass. They use wood in order to make fire and in order to cook. And so after some time, people were able to know how to use agriculture or to plant and to use animals as well. So they have the use of wind, water to water the plants, and some animals to help out in the preparation of the land. And still, the kind of energy or the source of energy we use at that time is still biomass. So in most cases, until the pre-industrial societies. So wood has been there, has been the main use or the source of energy by burning wood and some other biomass. So during that time, people are not too much aware about the available resources, because there's a lot of resources available at that time. But then came the time when industrial revolution began. So this is where there's a sudden uptake of the use of coal when we have the steam engine there, and we need to provide some heating by the use of fossil fuel. And now during this time, because of the industrial revolution, there is a sudden uptake of the use of fossil fuels, and also with because of this more energy, more uptake, there's also a quick exponential growth in terms of the overall population. And so when the population grew, the demand for energy also was growing. And then until such time that it came to the modern economy, there's an additional of oil and gas and mainly still from fossil fuels. And now there's a more and more uptake and more use of these fossil fuels. And now, because of this, now people are getting more aware about the finite availability of these fossil fuels, because fossil fuels are not easy to make. It takes millions of years in order for this to be prepared as a fuel. So now people are getting more aware of the resources and also looking at the potential environmental consequences of the use of fossil fuels. And now we're starting to feel some changes in our climate. We're starting to feel some damage that we see in our ozone layers. And so people are getting more aware about the various environmental effect of the use of fossil fuels. So the question now is actually on what is the next step? What is the next energy resource? Once fossil fuel is runs out, then what's going to be the next step? Or are we still going to continue to use fossil fuels until such time that there's no more fossil fuel available anymore? Or is this a time for us to actually look at other alternative resources or technologies perhaps to use these resources in order to have a more sustainable energy future? So in order to do this, we need to plan for the future. In order to plan better for the future, we need to analyze what's going on in the past, what happened in the past, and also what is actually our current energy use and the current energy needs. And then we can plan out for the future need or the future requirement that we need to do, and what kind of approach we are going to direct into the future. So if you look at in terms of the quantitative value, you can see that because of the advancements in technology, and you can see that the power consumption has exponentially increased from around only 100 watts per person per year as per capita. These values are actually based on the United States situation, but it's also a bit of an average value for most of the people. And here, from hunter-gatherers using the body energy, we have 100 watts or power, and then suddenly we have the ability to use fire, and then until such time the industrial revolution came in, then we suddenly have a very, very rapid uptake of increase of our primary energy use. And now, as you can see, this is about almost 12 kilowatts per person. And that's only in the year 2000. So how much more these days that everybody's almost using mobile phones and computers and internet. And so it's like every minute a lot of people are actually using these things, and it attracts or it uses a lot of electricity, and electricity is based from the use of fossil fuels. So the generation of electricity is still very highly based on fossil fuels, and that's going to be our main issue. Is we still use a lot of this power or our energy from fossil fuels. So in a nutshell, the use of our energy is when we ask how much exactly are we using per in the world. So we can see from here that our society uses really an enormous amount of energy. And this energy is around 5.7 times 10 to the 20 joules per year worldwide. And if you convert this one into power, then you can say it's 18 terawatts per year. Okay, so we will discuss later in the conversion from joules to power in a yearly basis. So that's 18 terawatts. And 18 terawatts is a really, really big, very big amount of power. So or on an average, if we divide it in a per person basis, we'll say that it's about 8.1 times 10 to the 10 joules. So to give you a bit of a context about how big is this 18 terawatts. So 1 terawatt can power 10 billion 100 watt light bulbs. Okay, so the capacity or the capacity of the light bulb is 100 watts, and you say 10 billion of that, that's only 1 terawatt. And then we are talking about 18 terawatts. So you have to 18 times 10 billion. There's a lot of light bulbs there. Okay, so an example of this, if you look at the sky at nighttime, so at the satellite, you can see that, in fact, at nighttime, there's so much electricity being used across the world. And that's a lot of energy coming from fossil fuels mainly. So what's the primary source of energy in the world? As I mentioned, it's more than 80% from fossil fuels. Before it was 85%. But because of the recent changes, the recent direction from governments about lowering the emissions, then there is a better uptake now in terms of renewable energy. So it's increasing, but still, majority is based on fossil fuels. So why is it that we use fossil fuel in most cases? So basically, fossil fuels are quite inexpensive, relatively. If you compare it with other energy sources, still we can say gasoline, some coal is still very inexpensive or cheap compared to them, because we don't normally put some externality cost for this one. And I will explain that one in the next slides. It is also readily available, at least at the present. So anytime still a lot of we have still a lot of reserves for coal and some fossil fuels. So we can still provide good amount of energy in the next several years. But the question is until how long? So that's a big question. And also fossil fuels have high energy density. All right, this is very high energy density. If you compare with renewable energy, it's way high energy density. So energy density is basically the amount of energy in a unit mass of a substance. So the more your energy density, the higher you can possibly provide some energy and power coming from that substance. So for fossil fuels, they have quite high energy density. And of course, for fuel of choice, we have oil, gasoline, diesel, because in most cases, this kind of fuels, especially for transportation, they are very good because they are portable, and they are major source of transportation. So portable means they can easily be transported. So if you compare this one with, for example, wind energy, you cannot bring the wind turbines with you all the time. So it's going to be a fixed one. But in terms of gasoline and diesel, you can get some 1 liter or 50 liters. You can take it with you and put in your car tank. And so it's very portable. It has high energy density. So that's why in most cases, fossil fuel is very, very attractive for the use of this in terms of these different various advantages. But of course, there are a lot of disadvantages as well, which we are going to talk about in this lecture. So big questions here. How long exactly will our fossil fuel reserves last, especially if we want to continue supply to more than 80% to the world? So according to some estimates, and depending on the uptake of fossil fuels in the future, we have at least 40 to 1,000 years of remaining supply. Of course, this 40 to 1,000 years is just an estimate. The low end, which is 40 years, is not very promising though. And if indeed it will not last that long, then we will have some major disruptions in our energy use in the future. By how much are we willing to pay for fuel if we have a choice? So how much for a fuel cost? Of course, if we want as affordable as possible, as we have also a limit on how much we can actually afford. Fossil fuel present itself as relatively cheap energy source, as most governments subsidize its externality cost. This is what we call as externality cost. When we use energy, we only pay the cost of our electricity bill, for example, or the cost of pumping gasoline to our car, but not on the cost of exploration of fossil fuel, the extraction, and the processing. These are hidden and are not reflected in their market price. So the externalities are usually seen in terms of pollution, wherein the exploration of fossil fuels can cause air or water pollution and degrade lands. And when fuels are burned, they release toxins and emissions that contribute to global warming. Knowing this externality cost, is it then wise from an environmental perspective to continue to use fossil fuels? And why? Of course, there are always some climate deniers, but an overwhelming evidence show that greenhouse gases, or GHG, that are emitted from fossil fuels burning has severe impact on our climate, though its magnitude and timescale of this impact are not yet really fully understood. Knowing this, it is more than important now to fully understand how we are utilizing our energy, what are our future energy needs, and what approaches to do to fulfill these needs. So the main challenge these days in relation to energy is on how to transition from a finite or non-renewable energy source towards a more sustainable energy. When we say sustainable energy, it is a form of energy that meets our present demand without compromising or putting into risk the ability of the future generations to meet their own demands or their own energy demands. This shift to sustainable energy is actually long overdue. But when we also need to address a very important question, can modern alternative energy sources provide the carbon-free energy we need? It is a big question, and this is something that we need to think about. This challenge is not only purely a matter of changing our energy sources and energy technologies, but it also refers to changing our way of life, the way we use energy, and how much we use, and basically changing our lifestyle. That means that not only do we need to change the way industry works, but much more on how we manage to change the dominant patterns of human society. So let us take a look on how big is the task in transitioning to a sustainable energy future. So is a sustainable energy future easy to achieve? At present, for example, the world power requirement is around 18 times 10 to the 12 watts, or 18 terawatts. We can also convert this one into 157,000 terawatt hours per year. So let's say our time frame for the transition to reduce the fossil fuel use is 50 years time. But in 50 years time, our energy use could also potentially double. All right? So it could potentially double. And why is that so? Of course, the globe is exponentially increasing. And so with the increase in population comes an increase in energy requirement as well. So this is just a very rough estimate of the example. So we're expecting that in 50 years time, 18 terawatts of power requirement will become 36 terawatts. So we're just making it simple. Let us say that for a current fossil fuel power plant, it can generate 10 to the 9 watts or 1 gigawatt power output. So from this power output for each fossil fuel plant, we can now determine how many replacement facilities do we need in order to produce the same power output in 50 years time. So what we can do is to divide the expected power requirement in 50 years time, which is the double of this one, it becomes 36 terawatts. So 36,000 times 10 to the 9 is basically 36 terawatts divided by 1 gigawatt of output, or 10 to the 9 watts. So from this, we can calculate that we need 36,000 replacement facilities in order to achieve the same power requirement. So when we say 36,000 facilities, this means that we need to build, okay, we need to build two major non-fossil fuel power stations every day for the next 5 decades or for the next 50 years. So we get this two, the number two is by dividing 36,000 by the number of days in 50 years. So this is around 18,250 days in 50 years. Of course, this is such a very, very big task. It's not easy at all because construction of two major non-fossil fuel every day for the next 50 years is not easy task at all. That is why substantial commitment is needed if we really want to proceed to replacing our fossil fuel use. So this is just a very rough example, but it gives us an idea of how enormous the challenge is, but of course it's not impossible. In order to fully understand why fossil fuel use is such a big issue, let us first discuss what are the drivers and motivations for energy discussions, especially towards sustainable energy. So this topic we will now discuss in our next video.